Just use the buttons. Got
Just
it.
use the buttons.
Just use the buttons. We're going old school today. All right. Just let everyone get settled for a second.
Yeah.
A lot of cobblestone folks. All right, so I think I'm going to get started. Hello, I'd just like to, before I get started, thank AFS for letting me come up and talk today. My name's Eoghan Donnelly, and I'm going to be giving a presentation about habitat factors contributing to the spread of invasive rusty crayfish throughout the Schoharie Creek watershed. So just to start, let's talk about what crayfish are. Crayfish are freshwater crustaceans. They resemble lobsters if you've never seen them before. They play critical roles in stream ecosystems because they're one of the only animals that affect both multiple trophic levels because they serve as predators, preys, and scavengers. They have some unique behaviors, like for competition, crayfish will have pheromone spray contests. Well, they'll spray pheromones out of their faces at each other, and whoever has the larger pheromone cloud will be the dominant crayfish in the area. And then they also directly compete and fight with their claws or chilipads, which you can see in the picture there, over things like habitat, structure, mates, and food. There's over 350 species of crayfish in the United States, and I just think they're neat. So in New York, there's 9 native crayfish species. Here we have a couple pictures of them. I'm going to step away from the podium a little bit. This is a northern clearwater crayfish. This is a virile crayfish. This is a rock crayfish, and this is a big water crayfish. All of those crayfish species are native to New York. However, there's a serious lack of information, particularly on distributions of native New York crayfish species. There's only one field guide that's been published on New York native crayfish, and it came out in 1957. It's called The Crayfishes of New York State by Denton W. Crocker. And in that publication, Mr. Crocker, he actually cites things from as far back as 1890 in terms of crayfish distribution. Since then, there's really not been a statewide field guide that comes out, so there's a serious lack of information in native crayfish distribution in New York. Invasive crayfish are a serious threat, though, across the United States and the world. In New York State, we have 4 invasive crayfish species. Those are the calico crayfish, the spiny cheek crayfish, rusty crayfish, and Louisiana red swamp crayfish. Invasive crayfish, they affect native crayfish species through direct predation, overuse of habitat. They sometimes have higher fecundity rates, and they can even transfer new diseases to native crayfish species. These invasive crayfish don't only affect other crayfish species, though. They can affect fish, plant, and invertebrate communities. In areas like the Great Lakes, rusty crayfish have raised serious damage. In Europe, American crayfish species have been spread across the continent, wreaking havoc in countries like Sweden and Italy. So this is a pretty serious issue across the world. Today we're going to talk about rusty crayfish, though. Faxonius rusticus. Rusty crayfish are the most widely spread invasive crayfish species in New York. There are species of crayfish that can often outcompete native crayfish species. There's been studies done that virile crayfish and northern clearwater crayfish have been outcompeted by rusty crayfish in a lot of areas. Rusty crayfish also do serious damage to plant communities. In certain lakes in Wisconsin, they're finding significant damage to plant beds and streams and lakes that had rusty crayfish introduced. In the Great Lakes, like I was saying before, they had an artificial reef project to help cold water fish spawning. However, rusty crayfish invasion was so extensive within these lakes that any fish spawning, the eggs that were there were immediately consumed. So now they need to go out and manually, physically trap all these crayfish to have their artificial reefs working. So these crayfish in particular can do a lot of damage to an ecosystem. Right now, everywhere in this like brownish color, that's where they're currently spread. This light brown color is their native distribution. They're native to the Ohio River Valley. But we're really worried about everywhere on that secondary map in red, in like that light red color, is at the most risk of being spread of rusty crayfish invasion. So you can see most of the Northeast as well as the Midwest is pretty vulnerable to their spread. So rusty crayfish, they have been introduced to the Mohawk River watershed, including the Schoharie Creek watershed. The exact extent of this invasion is unknown, though. People don't really go out and survey for crayfish too often, particularly in rural areas like Schoharie County. And there's really limited records of any crayfish species from the Schoharie Creek watershed. There's one record from like 1984 on the USGS website from the mouth of the Schoharie, not even up the Schoharie into the tributaries of big water crayfish. So there's really been no recent research on their distribution. So for this study, I wanted to compare habitat differences between sites in the Schoharie Creek watershed that were supporting native crayfish populations to sites supporting invasive rusty crayfish populations. I also want to identify the native crayfish to the Schoharie Creek watershed, and I want to collect voucher specimens from any sites where native crayfish were found for State Museum archives. So just to talk about our study area, the Schoharie Creek watershed, it covers an area about 930 square miles in central New York. It's a tributary of the much larger Mohawk River watershed, and it's kind of a unique river in that it flows from south to north. It starts from these little tributaries in the Catskill Mountains that come together, and then flow north to eventually drain into the Mohawk River. Currently, about 70% of land used within the area is undeveloped. Approximately 20% is used for agricultural purposes, and only about 5% would be considered urban or urbanly developed. The Schoharie River watershed was originally inhabited by the Mohawk tribe. The word Schoharie is actually a Mohawk word. It means driftwood. However, about 300 years ago, European settlers established significant agriculture in the area. This agriculture was so significant that during the American Revolution, Schoharie County was called the breadbasket of the Revolution. All this agriculture then peaked around the turn of the 20th century when approximately 80% of the land used in the area was used for agricultural purposes. Having this extensive multiple century history of agriculture in the area may have affected our study site pretty extensively. And I like this picture because it shows the area well for people who haven't been around there. It's a lot of rolling farm fields that goes into state land, forests and hills with nothing built on it. So I selected 10 sites from 10 different streams within the Schoharie watershed. The waterways I visited varied widely in size. I visited streams that were 6 feet across to the Schoharie River itself. And all sites sampled were north of the Gilboa Reservoir within Schoharie County itself. To collect crayfish, I used a dip net. I would kick over rocks, and any organisms underneath the rocks would get washed downstream where the dip net was positioned. I could then pick up the net and count and identify any organisms present. At each site, I sampled 10 meters of riffle, pool, and run habitat. And I also timed crayfish collection at each site so I could calculate CPUE. To collect water quality data, I used a YSI meter. I would always place the YSI upstream of any disturbance created during crayfish collection. I would then get water velocity readings using a flow probe. I would measure this in the run section of habitat at the sample site. And then lastly, before leaving, I would record elevation just from my phone. It was an easy way to get elevation readings. And then finally, online, I used the USGS has a conductivity portal. So in this picture, each one of these dots represents a barrier, whether that be a hanging culvert, a small dam. I was able to count and orderly rank all of the stream barriers separating each study site. I was also able to determine stream gradient using this website for every stream supporting a study site. I only counted barriers of significance, counted as significant and more severe, so they have these ordinal rankings like insignificant, significant, severe. So I only used barriers that counted as significant and higher. And then finally, I checked the area for any documented waterfalls, which there was 2 of, I believe, and I counted those as significant barriers. Then I used 2 sample t-tests for all of my parametric data. I used Wilcox rank sum test to compare all of my non-parametric data. And then we created kernel density estimates for each of the variables. We then mirrored those density estimates to create violin plot figures, and we were able to place each study site over those figures to show where it is in relation to these variables. So, 4 sites were found to contain rusty crayfish, and 6 sites were found to contain native big water crayfish. Big water crayfish were the only species of crayfish collected besides rusty crayfish. And rusty crayfish sites were found to have a much higher CPUE value than big water crayfish. Just to take a second to explain our figure here, on the y-axis you're always going to have the variable, then big water crayfish is on the left, rusty crayfish is on the right. Each one of these points represents a study site where a species was found, and we also have the p-value right above the legends. So rusty crayfish were found in sites with significantly higher conductivity than big water crayfish sites. Conductivity is a good indicator of total nutrient inputs within an area. This might be indicators of rusty crayfish living in areas with higher nutrient concentrations as well as associated production. Rusty crayfish were found in sites with significantly higher pH values as well. A higher pH value can lead to more nutrients being available within a waterway. So rusty crayfish might have been found in sites with more nutrient inputs as well as more nutrient availability in comparison to big water crayfish sites. Rusty crayfish were found at significantly slower water velocities than big water crayfish sites. I actually did a research project with Sunil Onyanta's BFS over the summer. We have a poster about it in the hallway if you want to talk to me about this later. But we were testing the water velocity tolerance of another Cambaris species, Appalachian brook crayfish, and comparing that to rusty crayfish using a flume. And with that other Cambaris species, we were also finding that they could tolerate significantly faster water velocities. And if you guys want to talk about that more later, you can find me in the hall with my poster. Stream gradient. Rusty crayfish were found in streams with significantly less steep gradient, even in differences in flow that occur throughout the year, because each one of these is a snapshot of the site at the time I visited it. But gradient is consistent throughout the year. So even if there's a difference in water velocity at the time I visited, you can see that these streams that can support in big water crayfish have a significantly steeper gradient, which leads to faster flows. The elevation of sites found to have big water crayfish was significantly higher than the elevation of rusty crayfish sites. Around the area, lower elevation streams typically have slower water velocities and more nutrient inputs. So these elevation findings sort of support our other findings from the project. Water temperature did not significantly differ between species sites. Anecdotally, I was speaking with other crayfish enthusiasts at last year's conference, and we thought that maybe water temperature played a role in rusty crayfish habitat selection. However, in this project, I didn't see any significant difference in the water temperature between sites supporting rusty crayfish and sites supporting big water crayfish. Also, I feel like a lot of the water temperature throughout the Schoharie Creek watershed is homogenized, particularly during sampling times with heavy flow in the spring. And then there was no significant difference in the number of barriers between big water crayfish and rusty crayfish. There was a trend towards big water crayfish being in sites which had more barriers separating them. However, this was not a significant trend, as you can see from the p-value. So rusty crayfish, they were found in streams with more nutrients and more nutrients available. They were also found to have higher and larger and more dense populations based on the CPW data. These extra nutrients into the stream might be aiding in production, which allows for an extra large rusty crayfish population. Certain nutrients in particular aid in crustacean reproduction, such as phosphorus. So by reducing eutrophication, we might be able to reduce production within these streams, which is supporting a large crayfish population. Stream velocity seems to be an important factor affecting the spread of rusty crayfish throughout a watershed. I believe big water crayfish and other Cambaris species might be able to tolerate faster water velocities, and this is just really an observation. But in every field guide and description of Cambaris species, they always describe them as having this smooth, rounded carapace. And rusty crayfish have this more angular shape to them. So this angular, these angles might be increasing drag on the crayfish and making them less aerodynamic. And streams with fast water velocities are sort of acting as refuges for native crayfish within an area. No streams are found to have both big water crayfish and rusty crayfish. I believe this is an indicator that big water crayfish are the native crayfish to the Schoharie Creek watershed, and that rusty crayfish have spread throughout all the habitat that they can, and now they have reached a point where they can't invade any of these remaining streams with big water crayfish due to the habitat factors I've laid out. And finally, people sometimes assume that rusty crayfish always outcompete native crayfish species, but I believe it is more to do with the individual crayfish species as well as the habitat factors within an area. Big water crayfish are very large crayfish with big claws for fighting. I found a big water crayfish in this mountain stream that was 14 grams, almost 3 times as big as any of the rusty crayfish I found. So I just don't imagine individual rusty crayfish coming up and outcompeting them for habitat or food or anything like that. However, in a high production stream where they're able to increase their fecundity and have a very large population standing, they then can come with their large population and outcompete these large aggressive crayfish species such as big water crayfish. So here's the current distribution of big water crayfish in New York, and you can see the Schoharie Watershed is clearly left out, so we can now add that into the map. And that's my last little thing for you. I'd like to thank Charles Codden, Mark Cornwell, Brian Heffron, Thomas Sadikowski, Elijah Creedon, and my Aunt Nancy for helping me complete this project. And I'd also like to thank the Schoharie County Conservation Association for their funding with this project. Anyone have any questions? Yeah.
So I know Rusties can hybridize with clearwater crayfish. Did you see any, well, one, did you see any clearwater crayfish in any of your sites? I don't know if you've had
No.
already. And two, do you think that hybridization could change their, I guess, habitat tolerances, if that makes sense?
Yeah. You can see that in a lot of other like fish species. I know more about hybridization of fish species where the hybrids are able to outcompete a lot of their original parent species. It's kind of hard for me to say because I was really working with Cambaris species and rusty crayfish are Faxonius. However, if they were to hybridize with maybe a more stream-oriented species, then they can tolerate those faster flows, lower conductivities, things like that. Yes, you.
You mentioned that you thought that the rusties had spread as far as they're going to spread within the watershed. How was that determined?
Well, there's no streams that were found to have big water crayfish and rusty crayfish left. And it seemed to be like a pretty solid line. I believe that they've spread as far as they can with that habitat that allows them to have a large population. However, once they get into these faster flower, lower production streams, they can maybe enter the stream and survive, but they can't outcompete the big water crayfish, and that's why we're not seeing any species overlap at any site.
Were there any sites that you surveyed that didn't have either species of crayfish?
No. I was able to find a crayfish at every site. Sometimes, some sites had like one crayfish, and I almost got washed away trying to find it. But yeah, no, I found it. Any other questions?
We have time for one more question.
Yes. Yeah.
From I guess, an ecological point of view, I mean, if rusty crayfish continue outcompeting our native crayfish, I mean, as we think about the broader food web, I mean, do we care? I mean, like, from a management point of view, are there broader implications for, passing on contaminants or, food supply for predators, or are there big picture kind of implications there?
Rusty crayfish have been found to dramatically affect a lot of fish spawning habitat. I was reading a paper from Wisconsin where they were really investigating rusty crayfish effects on plant communities. I think in one lake they had an 80% reduction in aquatic macrophyte beds. Obviously that's fish spawning habitat as well as food for a lot of different species. So rusty crayfish can cause a dramatic ecological effect that affects other species other than crayfish. And in fact that happens quite frequently.
Okay, good answer.
Thank you very much.
Yep.